about the topic force, and our presentations are going majorly to deal with the content in our course books and animations, which are going to stimulate the learning process which we want to achieve. First of all, when we talk about force, I want to first of all give some animations which are going to trigger the concepts of force that we are going to learn. So let us watch the video that is on our screens. This gentleman here wants to move this block, but then he can either push it. You can see the attempts trying to push. He's also trying to pull it. At the end of the day, we'll be able to see what that is. Then we have another gentleman, other gentleman here trying to pull, to move. At the end of the day, you can see when they are pulling, they are moving the object. So this one brings us to our discussion of the day, which is force. Now, from the animations we've seen, you saw that for us to move the object, they had to push, others had to pull. That brings us to the definition of the word force. So, force refers to a push or a pull that results from interaction of bodies. It is that which changes the state of motion of a body. As you saw earlier on, there was a push, there was a pull. The body did not remain in its original state. It had to move. There was motion of a body. Now, this force has the SI unit, which is the Newton, represented by an abbreviation of capital N. So, force has both magnitude and direction and is represented by a straight line with an arrow as shown. So you can see that line there with an arrow. The arrow represents direction, then the magnitude is the size of the force that has been applied. Then moving on, we can look at the effects of force. We can first of all start with the force can make stationary objects move. If you look at this animation here, you realize that the object that is being pulled was initially stationary. So once they start pulling, the stationary body has moved. The stationary body has moved. Then I think you can still see that video. The body is stationary at the start. Then once they start pulling, the body is moving. Then we can talk about it can increase the speed of a moving object. If a body is moving and then force is applied in the direction of motion, then we can see the moving object will accelerate. That is increasing the speed of the moving object. Then we can talk about stopping a moving object. So we can give an example of somebody running on a track and then somebody else stands in front of him and pushes and tries to put some force against the direction of the motion, then you realize that the moving object will stop. So that is also an effect of force. We can also talk about decreasing the speed of a moving object. If you try to pull a moving object, then you are going definitely to decrease the speed of the moving object. We can also talk about force changing the shape of an object, i.e., it can deform an object. This deformation, we can give a very good example of when we have an head-on collision of two vehicles. You realize that at the end of the day, they are going to be deformed. That one, we can present it as change of shape of an object. Then we can talk about this force making an object turn about a fixed point. That is the turning effect of a force. I think that's also another effect. We can also say it can change the direction of a moving object. It can change the direction of a moving object. Then moving on, we want to look at the various types of force that we have. We want to start with the first one, which is gravitational force. Refers to the force of attraction between any two bodies, e.g., force of attraction between the Earth and the Moon. And in this case, we are going to look at gravitational force as a non-contact force. The two bodies must not come into contact for the attraction to take place. We want to look at gravitational force of the Earth, and under this gravitational force of the Earth, we can define it as the force of attraction on bodies towards the center of the Earth. So all bodies that exist on the surface of the Earth are attracted by a certain force towards the center of the Earth. And this can be illustrated here by an animation that we have here, whereby this concept of force has originated from the scientist by the name Isaac Newton. And there is like a story we've been given before that before coming up with this concept, Sir Isaac Newton was seated somewhere under a tree. Then a fruit fell from the tree. Then from there he started asking questions around why didn't the fruit go up, but instead it came downwards. That is now through that inquiry or that questioning, that is how the concept of a gravitational force of the Earth came about. And we can see that that is the surface of the Earth. That is Isaac Newton seated there, and you've seen the fruit fall. So now the thinking about or around that concept brought about this gravitational force. Then we can move to the factors that affect gravitational force. One, the mass of the object. So the larger the mass, the stronger the gravitational force. So we can consider two bodies. If one is of maybe 100 kilograms and another one of 10 kilograms, then the one with 100 kilograms will experience a stronger gravitational force as compared to the one with 10 kilograms. That gives you a scenario of a stone and a feather. So the stone will experience a stronger gravitational force as compared to the feather. Then the second factor to consider is the distance of separation between the two objects. So the longer the distance of separation, the weaker the gravitational force. Those are the factors. Then we can look at some questions under that part. Somebody can ask you, what are non-contact forces? Already we've said gravitational force is a non-contact force. But under this part, we want somebody to tell us what these non-contact forces are. We can say they are forces which act even if objects are not in contact with one another. I believe as we keep on moving through the other types of forces, we'll be able to get more examples of non-contact forces. Then somebody else can ask you to explain why a ball thrown upwards returns back to the ground. Definitely, as we said, there is what we call gravitational force of the Earth. So the force of attraction by the Earth's gravitational force. So this ball will experience the force of attraction by the Earth's gravitational force. So that is why it will definitely return back to the ground. Then we want to move to the next type of force, which is centripetal force. As we know, this is a force which maintains a body to move in a circular orbit or path. Moving in a circular orbit or path. It is directed towards the center of the circular orbit or track. Examples of situations in which centripetal force acts include whirling a stone tied to a string. We have a centrifuge used to separate geese from milk. Then we have a car moving round a circular track or road. And as you can see on our right hand side, we have a circular path, and a string which is holding a stone, and we've been shown that the stone is being whirled round, so thus making that circular path. I believe we have a video here which is going to help us to also see. This is also an example, the earth revolving around the sun along its orbit. Even the moon can be moving around the earth. So let us check that video. You can see the whirling round. It is due to centripetal force. A very nice video. I think now the concept of centripetal force is coming about in those who are watching. And as you can see, we have this force directed towards the center, and that is the whirling around all the circular movement. Then from that part, we also have another one. There is a gentleman here in a glass, and you can see how the glass is moving around. Let me play that so that you can also see how the glass is moving around. Very nice. Gentleman is moving. You can even ask yourself why this gentleman is not being thrown either to the center or away. There is like a force which we are calling centripetal. There is also centrifugal force which we'll be able to learn in due time. Look at how that, now that is centripetal force. Very good illustrations. Look at that ball being whirled round. Very good. So at the end of the day, it's going to create a circular path, and there is that force towards the center. You can see with the green arrow. That one there now is centripetal force. Moving to the next part, we have magnetic force. Magnetic force is the force of attraction or repulsion due to a magnet. It is usually a non-contact force. Already we have said that non-contact forces, the object must not come into contact for the attraction to take place. So magnetic force is a non-contact force. And when we talk about magnetic force, we can talk about a magnet attraction or magnetic attraction, which is because we have defined magnetic force as a force of either attraction or repulsion. Now we want to look at this magnetic attraction. It occurs between a magnet and a magnetic material, or between unlike poles of a magnet. Then we have repulsion, which occurs between like poles of a magnet. All these concepts under magnetic force will be looked at more or in details under our Form 2 topic, which is magnetism. Then moving forward, you can see now we have those illustrations up there. We have two magnets being brought close together. The first magnet is north and south, then the other one north and south. So we have now the south and the north being brought together. They are going to experience attraction. Then the second one, we have repulsion, because those are like poles, south and south. Then the third one, we have north and north experiencing repulsion. And finally, we also said attraction can take place between a magnet and a magnetic material. So that is what is taking place there. So with us here, we have a video which will just illustrate attraction either between magnets with unlike poles, or a magnet and a magnetic material. As you can see, we have those two magnets very far away, but due to the force of attraction, you can see that is non-contact, but it's acting. It's pulling the other material, magnetic material, close until we have the attraction achieved. Or we can say those are two magnets with unlike poles, hence the attraction taking place. Believe you are getting those concepts right. Moving to the next one, we have upthrust force. Upthrust force is an upward force acting on objects immersed in fluids, such as liquids or gases. An upthrust can also be defined as the apparent loss in weight of a body immersed in a liquid or gas. So upthrust of a body can be given by a formula, or it can be expressed mathematically, which is or we can say it is formulated into something. We could say upthrust on a body is equal to the weight of the body when the body is in air minus the weight of the body when it is in a fluid. And upthrust is a contact force. As you can see, the object must be put in the fluid. So the figure below there shows an object inside a fluid, and in this case you can see those arrows showing that there is a force inside there trying to resist its motion in the liquid. That is a upthrust force. So we'll see an apparent loss in the weight. So some of the examples of situations in which apparent force acts include when balloons are rising into the air. Remember, air is a fluid, so we are having an apparent loss of weight. Then we have swimmers and boats floating. As a swimmer is getting into the water, you can realize that at the end of the day they are floating because we are having an apparent loss of the weight. Then we have bodies immersed in liquids weighing less than their weight in air, and that is what we have under that particular part. Then we have a numerical example. Now we can look at how we can calculate the upthrust force. We said that the example is a body weighs 100 newtons in air and 80 newtons when submerged in water. We are expected to calculate the upthrust acting on it. Then now you can check our solution. This solution will be determined through saying upthrust force is equal to the apparent loss in weight, and this apparent force is the weight of an object in air minus the weight of the object in water. So we have 100 newtons, that is the weight of the object of the body in air, minus 80 newtons, which is the weight of the object in water. In water. So subtracting the two, we are getting 20 newtons, which is now the upthrust force, or the apparent loss in weight. From that particular point, we move to the next type of force, which is frictional force. Frictional force. This is a force that opposes motion between two surfaces that are in contact. Frictional force is in fluids or liquids is called viscous drag, and it's a contact force, and it acts in the direction opposite to that of motion of the body. So you can check, those are some of the advantages of frictional force. We have writing, braking, walking, racing, lighting a match, stick. Those are the advantages, and you can see that figure up there. There is a frictional force acting in the direction opposite to that of the motion of the body. So you can check that this diagram up here, you can check what is happening, and now this frictional force has some advantages and we have listed them here, but then it also has disadvantages. What are some of the disadvantages of frictional force? Frictional force causes wear and tear. We also talk about hindering motion. Then it produces unwanted heat. Then it produces unwanted sound. What are some of the methods of reducing frictional force? The first way of reducing frictional force, if two parts are in contact, we can first of all use oiling and greasing. That's a very good way of reducing. Then we can talk about use of rollers. Then if it is in liquids, for example, water, air, we can talk about streamlining the bodies. Then we also have smoothening the surfaces so that we can reduce the friction. We can use ball bearings, and we can also use air cushioning. So I want us to stop at that point for today. I believe you enjoyed the lesson. I believe the animations stimulated the learning, and we believe to do more in other topics. So kindly watch and subscribe to our channel for more lessons, which I believe they are going to help you change your attitude and focus in physics. Thank you.